And the sector OAB has definitely got an area that's less than the area of the triangle AOC. So we have now a relationship, and we have that the area of the triangle AOB must be less than the area of the sector, right? OAB, which must be less than the area of the triangle AOC. So that must be less than the area of the triangle AOC. Okay. So let's see, can we figure out what these particular areas represent, or what are they? Okay. So just keep in mind here that by definition that the area of a triangle is half its base times its perpendicular height. Okay. So let's have a look at the triangle AOB. So if we knew the perpendicular height, okay, let's say here, okay, so if we knew this particular height here, this red height, uh, we know what the base is. We know that this particular length here is 1 unit. So it would be half 1 times this perpendicular height. But as I said earlier on, is that all the points on this circle in terms of radians, okay, and in relation to the cosine and sine functions, okay, have an x and a y coordinate. Okay, so the x. Oh, sorry. I should have said also that this particular arc here that has been drawn out. Okay, that this has a particular angle here. Okay, that this angle in radians, let's say is x. Okay. So what we now know is that this point B here. Okay. Uh, well, its cosine sine coordinate is, well, relative to x, it's actually cos x sine x. Okay, so actually its x coordinate here, okay, from here across, okay, would actually be cos x, and its vertical height here, okay, would actually be, well, this vertical height here would actually be sine x. Okay, so what we now know is that the area of this triangle is half its base. Its base is 1 times its perpendicular height, and its perpendicular height is sine x. So the area of the triangle AOB uh, must be sine x over 2. Okay? It's half the base times the perpendicular height. Okay, so half of 1 times sine is half of 1 is a half, and a half times sine is a half a sine. So what we end up with is sine x over 2, which must be less than, okay, which must be less than the area of the sector. Now just keep in mind that in the area of a sector, and when the angle is in radians, okay, when the angle is in radians, okay, is just that the area of a sector, right, is simply equal to half r squared times theta. Okay, so the area of this particular sector OAB, well, look, its radius is 1 unit because it's on the unit circle, and the angle it makes with the positive x direction, x-axis here, is an angle of x in radians. Okay, so x is in radians. Okay, so now what we have is this is r squared is the square root of 1. So it's a half times 1 gives us a half times the angle, which is x. So actually what we end up with is x over 2 here. And that must be less than the area of the triangle. Okay, so the area of the triangle AOC. Okay. So how the hell are we going to figure out this area of this particular triangle? Well, it's half the base times the perpendicular height. Okay, if that makes sense. So it's half the base times the perpendicular height. Okay, but let's just keep in mind. I'm just going to recall here also is that tan x. Okay, that tan of x is equal to the opposite. This is a perpendicular triangle here, okay? So tan of x is equal to the opposite over the adjacent. So the opposite is the length AC over the length OA. And the length OA is 1, so this implies that uh, tan x is equal to the length AC. So this length here is actually tan x, where x is in radians. So once again, we have the area of the triangle AOC is half its base, which is 1 unit, times its perpendicular height, which is